video is a review of the Edgenuity lesson, adding and subtracting rational expressions. So when you add and subtract fractions, the important thing is that you have to have common denominators before you add or subtract. So multiplying and dividing, it didn't matter. We just went ahead and multiplied or divided straight across. Here though, like I said, the denominators have to be the same before you can do the operation. So looking at this first one, our denominators match. They're both 3x, which is great. So what we can do is just add the numerators. 4 plus 5 is 9. And then when you add and subtract, the denominator just stays the same. It's important, though, before you think, oh, 9 over 3x, I'm done. Sometimes they will sneak in things that you can simplify. So for example, since this is 3 times x, we can go ahead and simplify this 9/3. So 9 over 3 simplifies to 3 over 1, or just 3 over x. Make sure when you simplify, x is in the denominator, so it has to stay in the denominator on the second one. This one, our denominators match, so I can just do the operation. 2x minus 4, they're not like terms, so they have to stay apart. So just to be sure, if you can ever factor anything, go ahead and do that before you move on to make sure nothing cancels out. So here on the top, I can divide it 2 out. Okay, so those don't match, so it's stuck the way it is. Sometimes they will match though, and you'll be able to cancel them out. Okay, so let's look at the second one here. It says x plus 1 over x squared plus 4x plus 4 minus 2 over x squared minus 4. So we don't have common denominators. So what I do, which the lesson in Edgenuity doesn't do, but this is what I do. Over on the side, I just write LCD, because I'm going to find the least common denominator over here. So I write down what the first denominator is. And I write down what the second denominator is. From there, I factor anything that I can. So for this first one, we have 3 terms. So we can just do what multiplies to 4 and adds to 4. It's going to be 2 and 2. So this is going to factor into x plus 2 times x plus 2, or x plus 2 squared, either way. Okay, the second one, we have 2 terms. So when you have 2 terms, you're always going to look for a difference of squares. It has to be subtraction. So we have that. This is x squared minus 2 squared. It's the same thing as x squared minus 4. So it will factor into x plus 2, x minus 2. Okay, so when deciding what your least common denominator is, everything from your first denominator is a part of it. So this whole thing I'm taking down. X plus 2 times x plus 2. Now, let's look at the second one. Is there already an x plus 2 listed down here in our denominator? Yes, there is. So you don't need to put another one in. If we did, it's just going to make our denominator more complex, and we're looking for the least common. Is there already a factor of x minus 2 down there? There's not, so we need to add that in as well. So this here is our least common denominator. That means I need these to match this right here. So to start off, what I'm just going to do is I'm just going to factor it. We already talked about this over here. This is going to be x plus 2 times x plus 2 minus, and we've already factored this one as well, x plus 2, x minus 2. So looking at the first fraction, what is this one missing? It has to match this. Well, it already has the 2x plus 2's. It's just missing this last x minus 2. So we need to multiply that in. Remember, whatever you do to the denominator, you have to do the numerator as well. Looking at the second one, it has the x plus 2 and x minus 2. So it's missing one of the x plus 2's. It only has those parts. It needs this part too. So this one, I'm going to multiply it by x plus 2 over x plus 2. So that now I have all 3 parts in there. So the first one, what we're going to have to do here is we're going to have to FOIL it because we're multiplying by 2 binomials. So first, outside, inside, last. Remember, if I'm ever going too fast, you can always pause the video. Over. Don't multiply out the denominator, just leave it. minus. Okay, on this one, it's not quite as bad because we're just doing 2 times x plus 2. So we can just distribute the 2 to both parts. So we end up with 2x plus 4. Remember, you can multiply in any order, so I went ahead and just snuck that x plus 2 in the middle there. Now that our denominators match, we can go ahead and subtract. So what I'm going to do is, over here on the left, I'm going to simplify this. So negative 2x plus x is just negative 1x. Now here, when you subtract this 2x plus 4, we are subtracting this whole thing. So it's kind of like you have to distribute the negative to both parts. So we're going to go minus 2x minus 4. And if we combine our like terms in the numerator, negative x minus 2x is minus 3x. Negative 2 minus 4 is negative 6. There are no two numbers that multiply to negative 6 and add to negative 3, so you can't factor that. It's stuck like that. So that doesn't simplify any further. Okay, so let's look at this next one. So over here on the side, again, I'm going to figure out what my LCD is, my least common denominator. First denominator is x squared minus 25. Second denominator is x minus 5. Factor anything that can factor. So this one has 2 terms, and they're being subtracted. And they're both perfect squares. So this is going to factor into x plus 5, x minus 5. The second part, there's nothing to factor. There's no squareds. There's nothing that we can pull out. It's just x minus 5. Nothing we can do there. So everything from the first denominator goes down. Okay, looking at our second value here, is there already a factor of x minus 5 down there? Yes, there is. So don't add in another one. It's just going to make it more complex. So we need our denominators to be this. We already know how to factor that. I showed it over here. Okay, this time we're adding. Okay, so the first denominator, we're good to go. It already is x plus 5, x minus 5. So we don't have to do anything here. The second one, though, this one is missing the x plus 5. So what we have to do is we have to multiply the top and bottom by the part we're missing, that x plus 5. So for this one, it's just 5 times x plus 5, so we can just distribute that in. So I end up with 2x over x plus 5, x minus 5, plus 5x plus 25 over x plus 5, x minus 5. Now that we have common denominators, we can go ahead and add. With adding, you don't have to worry about distributing the sign or anything like that. Just combine like terms. So 2x plus 5x plus 25 simplifies to 7x plus 25. Just combine the like terms there. And there it is. Can't factor anything out of 7x plus 25, so those are stuck. Okay, so what happens if you have a monomial like this, 5x and 4x? So over here on the side, don't have common denominators, so we're going to figure out what that is. Our first denominator is 5x, and our second denominator is 4x. Okay, so there's nothing here to factor, but what we do is we need to think of this as 5 times x and 4 times x. So when you have, it gets a little tricky when you have these numbers in the front. See back here, I'm going to show you the last page. We never came across that. See how there are no numbers in the front here and no numbers in the front? They're just those factors. When you have numbers in the front, you have to figure out what the least common multiple of these two numbers are. So what's the smallest number that 5 and 4 both go into? It's 20. So the least common multiple of the numbers in front is 20. Now we can ignore those because we already figured that out. Now everything else from the first denominator, it goes down. So times x. Do we already have a plain old x down there? we do, because this is 20 times x. So don't add another one in. That makes it more complex. So our least common denominator is just 20x. So to make this one 20x, all we have to do, so to make 5x be 20x, is multiply by 4 over 4. Now that's 20x. This one, to make 4x be 20x, we're going to multiply by 5 over 5. So we end up with negative 16 over 20x plus 30 over 20x. So now we can combine like terms. Negative 16 plus 30. And again, we can simplify here. If I divide the top and bottom by 2, I end up with 7 over 10x for my final answer there. Okay, so the tricky ones that they have in the video, I think I'm actually going to just skip on down to this one here, where you have fractions inside of fractions. So what we have to do first is you can't have two separate fractions when you want to do the keep, change, flip, or multiply by the reciprocal. So we've got to get these together first. So on both of them, let's do this up here. This denominator is x. This denominator is y. Everything from the first one goes down. Do we already have a plain y in there? We do not. So this is what the denominators need to look like. So this first one is missing the y. So I multiply it by y over y. This one's missing the x. This one's missing the x. And this one's missing the y. So what we get here is we have 2y over xy minus, multiply straight across, 4x over, you can multiply in any order, so y times x is the same thing as x times y, all over negative 5x xy plus 3y xy. Now we can put them together on the numerator and the denominator. So 2y minus 4x all over xy, because we have common denominators, and then negative 5x plus 3y. Okay, so now we just have one fraction divided by another fraction. Now we can do the keep. So leave the orientation of the top alone. Change this to multiplication. Flip. Keep, change, flip. Or multiply by the reciprocal. So when we multiply straight across, what's going to happen is we're going to have x times y times this factor over x times y times this factor. So these cancel out. And we end up, I'm just going to put the x first, with negative 4x plus 2y over negative 5x 3y. And nothing there can be simplified. You can't factor anything out. And as long as things are being added and subtracted, they can't be canceled.